Okay, so we're going to do more math induction. So let's move in. So for all integers greater than or equal to 0, 2 to the n minus 2 is divisible by 3. Okay, so again, we're going to show that for 0, n equals 0, it's true. So I put in 0 on the left-hand side, and I got 0, and that is divisible by 3. Check. Okay, so we're going to assume it's true for k is bigger than 0 for all the k's. Assume true for k. So I get 2 to the k minus 1 is divisible through, I don't know why I wrote that, we're assuming true for k. And so for 2k minus 1 is divisible by 3. So I'm just going to write what that I want that to say is that that's going to equal 3r, because I want to use it in the next statement, right? I'm going to be able to replace this with like a 3r, and so for some integer r. All right, so now I'm showing true for k plus 1. So again, you put k plus 1 in for n, so I get 2 to the 2 k plus 1 minus 1. So doing rules of exponents, I get 2 to the 2k plus 2, and if it's multiplication upstairs, if it's addition upstairs, is multiplication downstairs, so I get 2 to the 2k times 2 squared. So I'm looking to see how is it that I can use this fact. So I know 2 squared is equal to 4. Right? So what I'd like to do is, since I want to say divisible by 3, so here they get a little bit harder, I want to break 4 up into 3 plus 1. Then distribute 2 to the k times 3, 2 to the k times 1. And so this 2 to the k plus 1, 2 to the 2k times 1, and then this minus 1 carrying along, this can be grouped together and I can use my 3r. Then I can factor a 3 out of everywhere and I have it. So I've got that, I have 3 times, so I can just say that this is 3 times L, an element of the integers, so it is divisible by 3. Check. All right, so let me perhaps show you another one, and then I'll leave you with the next one to do. Okay, so let's go through it. Actually, I'm going to let you do this one. No, I'll do this one. I'll change my mind. Okay, let me do this one. Okay, so I want to show true for n equals 0. So I have 5 to the 0 minus 1. So that's 1 minus 1, that's 0. So that is divisible by 4. Check. Okay, so I want to assume true for n equal k. So 5 to the k minus 1 is equal to 4, and I'll just use, I have to use a different letter than k, right? L, and an element of the integers. Okay, so now I want to show true for n equal k plus 1. Okay, so 5 to the k plus 1 minus 1, I want to show is equal to 4, I don't know, some other letter, right? R, an element of the integers. Okay, so here, oops, I meant to write plus 1, right? I'm putting in plus 1. Okay, so now let's break this up. So I'm going to say that this is 5 times 5 to the k minus 1, right? So I just broke that up into those two terms. I'm looking at the fact that I want to show it's divisible by 4. So I am motivated to rewrite this 5 as 4 plus 1. So you're always looking to see where you're going. And so let me come across here. So now I'm going to distribute this 4 times 5 to the k, and this 1 times 5 to the k minus a 1. Okay, how can I use my inductive step? Do you see it? Here it is. That's this, yes? So continuing on, I can say 4 times 5 to the k plus 4l. And then can we rewrite this to say 4 times something? I sure can. 5 to the k plus l. Therefore divisible by 4. Check. Okay, so I'm going to let you do this one on Zoom, because I think you're getting the idea.